Hi everyone and welcome back to Sustainable Solutions Lab. I'm Milad and in this episode we'll explore one of the most relevant and systematic perspectives on urban mobility, the concept of intelligent mobility in smart cities, based on a 2022 editorial by Pribyl, Svitek and Rothkrantz published in Applied Sciences. Let's begin with core question. What exactly is a smart city? The term has been used globally and often inconsistently, but if we synthesize definitions from IBM, IEEE, the European Commission and the UK Department for Business Innovation and Skills, we can identify 7 core principles. One is technology is a tool, not the goal. A smart city is not about throwing sensors and AI at problems. The point is to serve people better. 2, citizen-centered design. From 15-minute cities to participatory governance, people, not devices, must be at the center. 3 is integrated and interoperable systems. Seamless connectivity between transportation, housing, energy, and waste system is critical. 4 is smart cities are not a product, they are a process. There is no finish line. Cities must continuously adapt and learn. 5 is cultural and behavioral change is essential. It's not just about decision makers using new tools. It's about citizens rethinking ownership, sharing, and community. 6 is sustainability and resilience are non-negotiable. 7 is digital, physical, and social systems must align. So, with that in mind, how does mobility fit into this bigger picture? Mobility is no longer just about getting from point A to point B. In smart cities, mobility becomes part of a larger system of urban functionality, equity, and environmental performance. There is a shift in paradigm from mobility to accessibility. In other words, the question is not how fast can I travel, but how easily can I access what I need? Smart mobility requires us to rethink about urban planning and land use, about energy consumption and emissions, about integration of shared and active modes, and finally about digital infrastructure for real-time data and multimodal services. Pribyl and his co-authors propose that mobility systems should be interdisciplinary, interoperable, and sustainability focused. Let's look at how these ideas show up in the papers included in their special issue. This editorial summarizes contributions across several real-world innovations. Let's look at 6 examples that illustrate the principles we just discussed. First is smart tunnel control systems. One paper introduces a systematic approach to urban tunnel control. Traditional systems close tunnels based on local data, like air quality and congestion. But the proposed approach uses citywide data, like overall traffic flow and service levels, to decide when and how to intervene. This leads to smarter, more context-aware decisions that benefit both mobility and environment. 2 is city logistics with cargo bikes. Another study rethinks urban freight with cargo bikes, particularly in cities like Budapest. Using a geometrical modeling approach, the researchers plan optimized logistics for shopping malls. It's not just about using green transport, it's about structurally redesigning how goods move in dense urban cores. 3 is business location optimization. A third study tackles location-based decision-making. Why does this matter for mobility? Because well-placed services reduce triple lanes, lower emissions, and improve accessibility, especially for underserved communities. 4 is hybrid multimodal routing algorithms. This paper presents an innovative routing algorithm that lets users switch modes mid-journey. For example, walking to a tram, then switching to a shared e-scooter. The system considers real-time data, discomfort thresholds like long walks, and urban constraints. It enhances user experience and promotes flexibility over private car dependency. 5 is evaluation of cooperative intelligent transportive systems, or CITS. CITS means systems that communicate and cooperate, vehicles, infrastructure, and user shared data in real time. This paper develops a methodology to evaluate these systems by focusing on 3 main core: functional performance, user acceptance, and environmental and traffic impact. This is crucial as more European countries pilot CITS, but struggle with standardization and evaluation. 6 is emergency access in housing estates. The final study zooms in on resiliency, especially how fire trucks access high-density housing. In many cities, poor planning leads to blocked paths, delayed response, and increased risk. This paper offers a systematic method to assess and improve passability, ensuring urban density doesn't compromise safety. In conclusion, what ties all of this innovation together? First is systems thinking, not part of the city operates in isolation. Mobility is connected to housing, commerce, environment, and safety. Second is data-driven but human-centered. Technology is a tool to support better outcomes, not a goal in itself. Three is integration and sustainability. Efficiency must go hand in hand with equity and resilience. Pribyl and colleagues emphasize that intelligent mobility is not just about new tools or vehicles. It's about transforming the structure, logic, and ethics of how we move as individuals and as a society. Smart mobility is the backbone of future cities, but only if we build it thoughtfully. If you are a student, planner, or researcher, this editorial is a great entry point into the next generation of urban mobility strategies. If you found this video useful, please like, share, and subscribe to Sustainable Solutions Lab, where we bridge academic insight with practical systems. See you in the next video.